Today is 19th of October 2020. We are discussing queuing theory, and we will mark out the formulas where we have found out Ls is equal to rho into 1 minus rho. That is, we have discussed Lq is equal to Ls minus lambda by mu, and which upon solidification became rho square by 1 minus rho. Now Wq as a formula is lambda by mu into mu minus lambda. Okay, and Wq is again also can be related by Little's equation. If you can remember, in last class we have discussed our Little's equation, and where here it is, this Wq is equal to Lq by lambda. Okay, Wq is equal to Lq by lambda. This formula also works, and Ws is equal to Wq plus 1 by mu, which upon uh, simplification gives us 1 by mu minus lambda. Okay, these are the major formulas. Now there are a few more formulas, like the probability that the Q size greater than is equal to capital N is equal to rho to the power n. Okay, and probability that the waiting time in Q is greater than T, that will be given by integration T to infinity rho into mu minus lambda, rho into mu minus lambda into e to the power mu minus lambda into w and total whole dw. Okay, so rho, sorry, I have made a mistake. The probability that the waiting time greater than q is equal to, this is lambda, sorry, lambda into, this is also 1, lambda into 1 minus lambda into e to the power minus mu minus lambda bracket into w and whole multiplied by dw. Okay, this is the probability that the waiting time in q is greater than equal to t. The probability, these are few special cases, the derivation is not required. This is just for information that the waiting time in the system, this was in q, this was in system, greater than t, that is given by t from t to infinity rho into mu minus lambda into e to the power minus mu minus lambda to w and whole multiplied by dw. And you need to remember that the traffic intensity rho is equal to lambda by mu. Okay. So these are the basically formulas we are going to need. Let us understand with a problem.
হ্যালো স্যার।
হ্যাঁ বলো।
স্যার ডাব্লিউটা কি ডিনোট করে একবার বলবেন?
কোনটা?
ডাব্লিউ মিউ মাইনাস ল্যামডা ইনটু ডাব্লিউ।
এটা বলছো?
ডাব্লিউটা কি ডিনোট করে?
কোনটা? ডাব্লুটা?
ডাব্লিউটা হ্যাঁ ইয়েস স্যার ডাব্লিউ।
এটা হচ্ছে তোমার ওয়েটিং টাইমটা।
মিউ মাইনাস এই ডাব্লিউটা হচ্ছে ওয়েটিং টাইম, তাই তো স্যার?
ডাব্লুটা হচ্ছে ওয়েটিং টাইম, যেটা কিনা টি থেকে ইনফিনিটি পর্যন্ত হতে পারে। এই যে ওয়েটিং টাইম ইন দ্য সিস্টেম বলছে, এখানে এই যে ওয়েটিং টাইমটা হচ্ছে ডাব্লু, যেটা টি থেকে ইনফিনিটি হতে পারে।
ওকে স্যার।
Now let us solve a problem for a better understanding. We have a problem that, say, here is example 1. It says a TV mechanic finds that the time spent on his job has an exponential distribution with mean 30 minutes if he repairs the sets in order in which they came in. So I am repeating the line. A TV mechanic finds that the time spent on his jobs has an exponential distribution with mean 30 minutes if he repairs sets in order in which they came in. Okay, so he followed the order. The job has came in. So in such case, he takes a mean of 30 minutes for each job. So from that you can understand that he does solve a problem. If he solve a TV, he repairs a TV in 30 minutes. So in unit time, he repairs in unit time 1 by 30 number of TVs. So mu will be equal to 1 by 30 per minute. Okay, mean repair time 30 minutes. So in unit time, in 1 minute he repairs 1 by 30. Now if the arrival of sets is approximately Poisson distribution with average rate of 10 per 8-hour day, you need to understand that 8-hour day means he works 8 hours in a day. And 10 number of sets come in that 8-hour day. So in 1 minute, how much set will come? Total 10 number comes in how many minutes? 8 hours into 60 minutes. So upon simplification, it gives 1 by 48. So in 1 minute he can repair, the sets come in 1 by 48, he can repair 1 by 30 in every minute. So from here we can find out mu and lambda. Now the problem is, what is the mechanic's expected idle time each day? Okay, now we have to find out idle time each day. And next is, how many jobs are ahead of the average set just bought in? That means you have to find out the total queue size. So the problem is, how many jobs are ahead of the average set just bought in? Then how many is just lined up? So first problem first, this guy will be busy in is actually lambda by mu quantity of time, lambda by mu times of total quantity of time. He will be remain busy. I'm writing it in a very clear way. The mechanic will be busy lambda by mu times of the total time. So lambda by mu into the total time is 8. So upon putting the values, we get 5 hours. So the idle time becomes 8 minus 5 is 3 hours. Now our next question says, how many jobs are ahead of the average set just bought in? So that means we have to ignore how many sets are getting repaired, and we have to understand that we are asking about the LQ. So the formula of LQ is LS minus lambda by mu. So LS minus lambda by mu actually gives you rho square by 1 minus rho. So rho is lambda by mu. You just put the values and tell me the answer. Lambda and mu are known. Please tell me the answer. Anyone got answer?
One 1.042.
1.042. I do not know the answer. 1.042. If it is so, then that means this number of jobs are just ahead of the job just bought in. So this is the number of jobs. Okay. So now let us discuss the second problem. write down. You can take short notes, do not need to write the whole sentence. Okay. In a supermarket, the average arrival rate of average arrival rate of customers is 10 every 30 minutes following Poisson process. The average time taken by a cashier to list and calculate the customer's purchase is 2.5 minutes following exponential distribution. So cashier takes 2.5 minutes following exponential distribution to complete billing. Okay, this is the problem. The rate of arrival of customer is 10 in every 30 minutes following Poisson process, and the cashier takes 2.5 minutes on average following exponential distribution. Now the question is, what is the probability that the queue length exceeds 6? Second question, what is expected time spent by a customer in the system? Next question, what is the expected time spent by a customer in the queue? Okay, this is the question. Solve it and then tell me how do you solve this process, and we will discuss on it. First, solve the problem, then we will discuss how did you solve it. Whenever a person completely solved it, just nod me here, sir, I am completed. I am waiting for you. Solve it. While you are solving, you can also discuss if you find any problem, or you can share your thinkings. What will be your first step? What will be the first step?
So 10 every 30 minute,
Hmm.
so it converted into the lambda equal to 20 hour per customer rate of
20 hour per customer. I mean 20 customers per hour.
20 customer per hour.
Now, okay. Now then,
Then sir, mu also converted in the per hour term.
so you need to convert both. It is better to convert
Yes,
all
sir.
these terms in minute. So these all are given in minutes. So if you work with minute, then it will be easier. In both cases, the answer will be same.
Yes, sir. Yes.
Okay, very good. So have you done it?
Sir, it just continues.
Okay, okay. Solve it. Himanshu Sharma, roll number 127. Roll number 127, Himanshu Sharma. He is not present. Ankit Rajak, 147. Ankit Rajak.
Sir, what is the probability of that the Q length exist
6.
exceed 6?
6.
So that means a root to the power 6.
Yes.
Okay, sir.
Then
Then sir, mu also sir 2.5.
no, mu is not 2.5.
Mu.
One customer takes 2.5 minutes.
মিউটা 2.5 কি করে আসছে? মিউটা 1/30 হবে না?
স্বদেশ আরেকবার বলো ভালো করে, স্লোলি।
2.5 কেন নিচ্ছেন এটা বুঝতে পারলাম না। মিউটা তো 1/30 হবে না?
See, lambda and mu both are a particular number per unit time. Okay, so lambda is 10 per 30 minute. So 10 by 30 per minute. Okay, and mu, where
Yes, sir.
the cashier takes 2.5 minutes for each customer. So how many customers per unit minute?
1/5. 1/2. Yes, sir.
10 sir, 10.
10 sir. 1/2.5.
Yes. Right. Now you put the values. So lambda is 10 by 30 per minute. Mu is 1 by 2.5 per minute. Now you put the values and find out all other parameters. হ্যাঁ বলো আরেকবার।
2 minutes
2 minutes, এটা কোনটা বলছো?
in the system.
In the system 2 minutes. 2 minutes কি করে হয়? তুমি একটু কমন সেন্স লাগিয়ে ভাবো, ঠিক আছে? অঙ্কের সেন্স না, জাস্ট সিম্পল সেন্স লাগাও। দেখো, যদি একটা কাস্টমার বিলিং করতে 2.5 মিনিট লাগে, তার আগের কাস্টমারটাকে তো অলরেডি 2.5 মিনিট দাঁড়িয়ে থাকতেই হবে, তাহলে এত কম কি করে হতে পারে? কোন ফর্মুলাটা তুমি ইউজ করছো?
Sir, 1 divided by nu minus lambda.
তুমি বার করছো সিস্টেমেরটা, তাই তো? তো সিস্টেমের ফর্মুলা তুমি যদি ইউজ করো, আরেকবার বলো তুমি কোন ফর্মুলাটা ইউজ করেছো?
The second data 1 minus nu by lambda.
সেকেন্ডটা মানে হচ্ছে ইন কিউ, কতক্ষণ কিউতে থাকবে।
Now, sir, in the system.
ইন দ্য সিস্টেমে থাকলে তোমাকে এলএস এর ফর্মুলা নিতে হবে, সরি ডব্লিউএস এর ফর্মুলা নিতে হবে। ডব্লিউএস এর ফর্মুলা হচ্ছে ডব্লিউ কিউ প্লাস 1 বাই মিউ।
That WS equals to 1 divided by nu minus lambda.
আচ্ছা, করে দেখছো কত আসছে?
ওটাই 2 আসছে।
ওটাই 2 আসছে।
15 আসছে, 15 মিনিট আসছে।
হ্যাঁ, এরকম 15 মতনই আসা উচিত, কারণ দেখো না, একটা যদি তুমি 2.5 মিনিট মানে 2.5 মিনিট যদি একজনের বিলিং করতে লেগে যায়, তাহলে তার আগের লোকটাকেই তো 2.5 মিনিট দাঁড়িয়ে থাকতে হবে, তাহলে 2 মিনিট
Yes sir,
লাগে। দেয়ার মাইট বি সাম প্রবলেম, আমি খাতাটা না দেখলে তো বুঝতে পারবো না কোথায় কি প্রবলেম।
sir WS equal to 1 by mu minus lambda.
হ্যাঁ,
স্যার ওখানে তো ভ্যালু পুট করলে স্যার 50 মিনিটই আসছে।
সেটা মানে সেটা ঠিক আছে, সেটা একটা জাস্টিফাইড ভ্যালু, that is okay, but 2 minutes it cannot possible, because you just understand the person just in front of you, you are number 1 in the queue. So the person getting service in front of you, he is taking 2.5 minutes. So
Yes,
you
sir.
are,
Yes,
so
sir.
you,
15 minutes.
okay
15 minutes.
then it's fine. Okay, so you have found out that the expected time spent by a customer in the system is 15 minutes. Now find out what is the expected time spent by a customer in the queue. Use Little's formula and find out. Or you can just use any formula, it doesn't matter.
মানে হচ্ছে 5 স্যার 12.5 স্যার
12.5, very good. Because WQ will be equal to WS minus 1 by mu. Or you can use the little
Lambda by
formula also. Yeah, that formula.
mu
also.
minus
In all the cases, the answer will be same. Durva, is it clear now?
Yes, sir.
Okay, okay, fine. Actually, my voice is not clear. That is not a network issue because I have got cold, so that's why might be my voice is little clumsy.
স্যার ইটস
Hello.
স্যার
Please come again.
ইয়েস স্যার স্যার ওটা স্যার নেটওয়ার্কের প্রবলেম ছিল স্যার
হ্যাঁ তখন নেটওয়ার্ক প্রবলেমটা হলো দেখলাম আমার সব রেড রেড ইয়েলো ইয়েলো হয়ে যাচ্ছিল নাও ইটস গ্রিন ইটস ওকে নাও okay it's 11:47 and it will take much time so in this festive time I will not take much time. Okay, let us stop here and the next class will be I think after puja na because vacation is from 22 I think. So 22 is Thursday. Okay, so we'll end up here.